Yanis, can you hear us?
Yes, hello.
Can you share your screen also?
Should I already start or just do I need to test it out?
Yeah, just share the screen. Yeah.
Okay, one moment. Yeah, so
Yeah, so before you sharing, I want to present Yanis. So he's presenting today a topic on GenAI and quality engineering. He's from Accenture, and yeah, the stage is yours, Yanis. You can start.
okay. Yeah, so as it was already said, I'm Yanis. I'm from Accenture. I'm a test automation specialist, and I will be presenting a little bit about what type of GenAI solutions we are doing in Baltics. So I think we can start. 1 second. Yeah, so kind of the agenda of this presentation. So we're going to do a kind of a quick reminder, the difference between generative AI and regular AI. We'll check what type of opportunities we have identified for the quality engineering. Then we'll look in more in detail some of the use cases kind of in depth that we have already kind of tested and did some pilots with. Then check some data regarding the value proposition, briefly look at some of the limitations, and well, also of course the capabilities of generative AI in regards to software testing. And yeah, that's about it. So as mentioned, the quick reminder, kind of how these two differentiate. I'm guessing that most of you here already know, but maybe if someone is new, someone doesn't know, and to kind of specify what I'm going to be talking about. So I'll be talking about generative AI, but the key differences are that traditional AI solutions, they are type of machine learning that usually specify kind of are very focused on a certain specific task or specific action. Very common things would be like classification, clusterization, predictions, and things like that. So they are not very good at creating anything new. They are better at recognizing something or predicting something. And good examples of that would be things like recommendations in variety of places like Netflix, Amazon, and of course variety of search algorithms like the ones used in Google. And on a different side, we have the generative AI, which uses large language models that are trained with existing artifacts, and then they can create new artifacts. So data sets that are fairly large in scale, and they are very similar to realistic data sets. So sometimes we are even struggling to differentiate whether it's generative AI created or is it real. And yeah, they can do a variety of content, mostly as would be text, images, video, audio, and of course also software code that we probably will briefly touch it here. And examples, of course, is the OpenAI GPT models, the Meta's Llama model, the Google's Gemini, and there are many more. More with each year, actually. So once we've done that, we can look at what are the kind of key opportunities that we will encounter in the quality engineering that we could potentially leverage some of the generative AI tools. So under the else, we have obviously the generation of actual tests. So any new piece of code needs to be tested somehow, and we could use AI tools to create tests for testing them. We could, of course, also generate or validate requirements. So, well, before each feature even gets tested, we first need a good set of requirements. So we could try to use generative AI for creating or improving those. And there's also a possibility of using some sort of a chat copilot that could be used for requirement creation or validation purposes. Then in the automation section, we have we could validate the coverage of the test. Well, for automated tests, it's more simpler, but especially for manual tests, it might be quite tricky to say how much is actually covered. So generative AI could potentially help in that. For the automation specifically, we could generate parts of the code, especially things like page objects with locators, because it's kind of tedious task to do, and AI could do it quite well. We could create tests for APIs. We could also, of course, create tests using different sources of information, like here it mentions the audio, video. We could help with maintenance, like self-healing automation. We could create an exploratory test without actually giving guidelines and just kind of letting the AI loose to use its creativity to touch that to kind of test the solution. And we could also do a basic code analysis, which is not specific to test automation, but it applies to pretty much anything created with any code. Then in reporting, we could try to use the generative AI for improving the reports or creating the reports in the first place. We can try to detect existing defects or maybe analyze them and to identify what is the root cause of those defects. Well, for test data, it's the test data creation. And we could also try to use them to support the defining of strategy. You will notice that some of these are highlighted. The highlighted ones I will go in more detail and kind of explain some of the pilot tools that we have tried using for them. Some of them have been used already here in the Baltics, and others are tested by our German colleagues. So I might not be able to explain all of them in great detail, but the ones that I have used, I will try to explain to the best of my abilities. So the first one I would like to touch is the requirement analysis. So the situation is that whenever you're working with a new feature, you need to have good requirements for said feature. And well, obviously that it's quite could be time-intensive task to create and properly define those requirements. And of course, there's also a risk that the requirements could be defined in a way that might be misinterpreted by someone. It might be ambiguous, so to say. And these kind of discrepancies between the understanding of the requirement author and the developer or tester could create a bit of rework on extra effort, and we want to that and of course speed up the process. So what we could do is use generative AI tools to take a look at existing requirement definition, try to find any issues with it, compare it to a predefined list of kind of a checklist that specifies what each requirement should include, and then make suggestions of how requirements would be improved. So that way we can improve the efficiency of the process. We can enhance quality, of course, because this way we'll have this sort of predefined strict rules, and this will ensure that all the requirements are written in a cohesive way across the project. And of course, this will also allow us to get a very fast feedback, because if we were to use a traditional peer review process when one person writes the requirements and passes them to other to review, well, that usually takes a bit of time. But with when using an AI solution, well, we don't really need to wait for the AI to be free to act on it. It can act almost instantly, so you can get a fast feedback, and this would improve the speed of the whole process. And a kind of an example implementation of how this could be done. So we can use a task management tool like Jira, where we can set it up orchestration in a way that during a certain action, we trigger a webhook. Then that webhook further calls our customized tool, which this example is placed in Azure. And this tool retrieves data from the Jira ticket, then formats it, uses predefined prompts, and combines it and sends it to an LLM, which then creates a list of possible improvements, and then we paste these as a comment. So the requirement author can then look at the comment, identify which of these are good, and then apply those to the ticket and repeat the process a few times to make sure that the final ticket is well defined, cohesive, and there is no room for kind of misunderstandings when developing the solution. So the next use case that we can look at is the test scenario creation. And here, the requirements that we briefly just looked before could be used as an input. So the issue, of course, is that creating tests is quite time-consuming process. Anyone who has done that will know that, because, well, even if you are able to quickly identify all the things that need to be tested, you'll still need to spend a bit of time to actually writing everything down in a good format so that could be used for later on in testing. So again, to speed up this whole process, we could use the generative AI and feed in the requirements from the story, and then use these requirements to already generate ready test cases that are clearly defined, all written out, and pretty much ready for execution, or maybe a review, because usually you would want to check the output before kind of instantly passing it onwards. And just like with the previous solution, this allows to speed up, streamline the whole process. This it ensures that the format for all the tests is more consistent, because, well, obviously, it's as an automated tool, it's not going to put a completely random things out. So, and we are, through prompting, we are controlling what type of output it actually provides. And the solution is, of course, scalable. So unlike with a regular person, they can only work at one item at a time. But for an AI tool, it's not really an issue to simultaneously handle multiple tasks. And a solution, but possible implementation for the solution. You will notice it's very similar to the previous one, that we are also here leveraging Jira Webhook functionality, because it's very convenient and it's easy to integrate with most projects. You don't have to build a separate tool for that. You can just use what's there. And just like with the previous solution, we can trigger this through, for example, a state change. When the ticket is ready for development, we can expect that the requirements are good and they can already be used for creating tests. So our solution will retrieve information from the Jira ticket, then format it, combine it with prompts, then perform requests to an OpenAI, well, in this case, but it could be a different LLM model as well, and then format the response and create and using API request will create Zephyr test cases. Here we are using Zephyr because it's kind of pretty much an industry standard for anyone who uses Jira, but the solution can be easily adjusted to use a different framework. For example, we could use the Azure boards and their testing functionality, but yeah, the solution here, it just uses Jira because it's a good example and most people recognize it. And here is a kind of a brief example of how it could be this use case. So you would have some form of business requirement, as I said, which would be ready, and here it describes the creation of some sort of template. We don't really need to dive into this too deeply because we don't have enough context to kind of do that. But we can see that the table on the right kind of highlights more or less kind of how the process would go. So for analysis, it's notably faster with using generative AI because we basically just need to copy the text and combine it with some form of prompt. So it's relatively fast. Then when we are creating, we're doing the test scenario planning. Well, obviously there's the prompting time and response time, and then we need to read the output, which, well, if you're doing it yourself, you don't need to reread what you wrote, but with an AI, you still need to check that. Then we would generate that. Again, it's relatively fast, and at the end, you still need to do some sort of proofreading and checking to make sure that the output is actually what you want. And anyone who's working with AI tools will know that it's a good idea to always check the output. And in this specific example that was tested by our German colleagues, we can see that, well, we reduced time for creating tests from 75 minutes to about 30 minutes. So obviously, it will differ quite significantly between different business requirements and different projects and different situations. But I think it kind of highlights how this could affect the manual test creation as a whole. So next use case. Well, we were talking about the manual tests, and now we can sort of switch to the automated ones. And again, a common problem with automated tests is their maintenance. Well, and this use case also applies to creation, but maintenance is kind of one of the things that's really kind of tedious when you're doing automation, that something changes in a page and then you need to find where things changed and then manually change it. And especially when you're talking about the web locator or the page object creation, it's very monotonous task. So you're basically just doing repetitive actions of copying locators from the page and then creating them in a certain format. And while traditional tools can automate some, if your project is using any kind of modifications to the framework or custom libraries, you're probably not going to find off-the-shelf solution that can automate that process. So again, we can use generative AI here, and the unique functionality that generative AI provides is that we can define our own kind of customizations to a framework by giving it examples of how the output should look like, and then generative AI will try to recreate it. And that way we can ensure that not only the output has proper web locators, but it also can align with our whatever coding standards we have. And yes, so as with other tools, it speeds up the process. It makes it, it improves the overall quality, because this we can faster do these updates and fixes for automation maintenance. So we don't have to wait for something to be fixed before we get good regression results for the automation. And kind of briefly, an example of how this could be done. Well, we could, assuming if we're doing this fully automated, we could hook it with some form of webhook within the repository, but this process could theoretically also be called by the developer themselves, whoever is either maintaining automation code or making changes to the pages, to the web pages. And then we are sending the HTML page to our tool, which first strips it from any kind of stuff that is not really helpful for identified locators. Then it sends the whole message to OpenAI, and that OpenAI will provide a page object, which we then can either simply return or maybe already created as a commit for the project. And this way it could theoretically be completely automated, and you just need to check at the end to see if the code is good. So another solution which I mentioned, we could use a multimedia input. So let's say in your project you have after a function gets implemented, you have a demo that is shown to business representatives, and someone who has implemented the functionality guides them through in detail, explaining how the functionality works. Well, we could use that as an input for creating an automated test or even manual test, depending, well, assume if for whatever reason we don't have manual tests for that yet. And the recording could also be from just a discussion about how the feature should work. Someone explaining how it works is enough for us to kind of try already using that for creating the automated script. So first we would take the recording, grab audio from it, and then convert it to a text. And then once we have a text, we can use something similar to what we used previously. We would feed this text to an AI and ask it to create structured steps, right, in a normal format, or maybe already in some sort of automation framework. And yeah, so the benefits obviously would mean that we would have an easy way to create these automated tests without a lot of manual effort. We can involve business people for this type of automation because they don't need to understand an automation code. It's enough that they in detail explain how the use case goes. And yeah, the whole solution is in the cloud, so obviously that there are certain benefits from that as well. And kind of basic example of how this goes would be that we have some form of video file recording. As I said, we extract audio, we then process natural language, which could use generative AI, but there are even additional AI tools that could also do this. Then we use this transcript together with a variety of prompts and possibly examples. And then this generates us a manual test case and even an automated test case if that's what's required. In this example, it shows a certain type of framework, but we could easily tune this to use a different kind of, like a 𝐒𝐞𝐻𝐭𝐞 or maybe already existing Selenium framework. And yeah, as I said, it speeds up the process. At least in the example that was done, we had about 80% speech recognition accuracy, and obviously, as I mentioned, this can speed up the process and reduce effort needed for creating individual tests. And a very similar example is that instead of using multimedia, we could also use a API documentation. So anyone familiar with API testing? Yeah, so if you have a good documentation, we can use that as a basis for creating automated tests. And well, the process is pretty much the same as the previous one, except we swap out the transcript with an API documentation, and of course we would also modify the prompts. But beyond that, the use case is very similar. Well, and once we have all these tests, we have created very quickly and rapidly with AI solutions. We do need to sort of analyze the results because tests without checking the results aren't very useful. So for that, the issue is usually that if you have a lot of tests, it requires quite a bit of time and effort to go through and investigate each and every failure. So again, we would like to speed up the process, to make it fast, to make it less effort intensive, and not require special skill set for people performing it. So we can leverage AI solutions and feed them both the software code, the automation code, as well as the reports, and try to get already a human readable report out of it without spending a lot of manual effort. And yeah, and of course, this would speed up the whole process of getting the results. It would allow us to do more testing because we're able to analyze reports much quicker. And we would also, and yeah, this is the kind of graphical explanation of the solution. So we have console output, which sometimes it's very good, sometimes it's not very good. And then we can use this together, combining with the automation code and maybe as well as an application code if we can easily retrieve it. And then feeding it all that to an AI tool, we could create a report that easily highlights the failures and even the causes of those failures, if we have provided enough information. And the last solution that I'm going to briefly look here is the synthetic data generation. Again, one of the challenges in testing is that you need not only actions to perform, but you'll need data to put in. And depending on the application, you might need a lot of data. And when you're dealing with data, sometimes there is an easily available source, but sometimes there's not. You may be able to retrieve data from production, but because of GDPR and other limitations, you have to be very careful about that data. And if you are kind of if there are cases where the data is protected, so you cannot get that at all, even if with scrubbing, or maybe the application hasn't reached production yet, so you don't have any data at all. So we can use AI solutions to create test data. Generative AI is pretty good when you're working with a complex data or data that requires creativity, at least in my experience. But if you need large quantities of bulk data, then we'll encounter the problem that usually we would need to pay for the amount of data that gets transferred to an AI model. So if you're going to create hundreds of thousands, maybe millions of entries, then it will be very expensive process. So for that, we can actually leverage a regular AI or traditional AI. There are tools that allow we can sort of to quickly learn from a structured data set and then produce a data set that is very similar. But if you need more creativity or you don't have an examples of that data available, then generative AI is pretty good tool for creating that. And yeah, as I mentioned, this creating synthetic data with generative AI tools obviously avoids any concerns about data privacy because all of the data is synthetic, and because we now have we have a way of easily generating a lot of variety of data. We can also improve the coverage, and we don't have to worry about someone spending hours and thinking about how data should look like. So, as mentioned at the beginning, we'll briefly touch the value proposition. So, this is data based on both our German colleagues as well as the Gartner, and part of this is from actual experience, part of this is from a variety of polls within the industry, and we can see that in the use cases that I mentioned, the test generation, automated code generation, and as well as reporting, we can see that those trying to use these AI tools are getting improvements both in the productivity, quality, as well as delivery speed. This isn't necessarily with the two examples that I used. Some of them are related to that, but as I mentioned, these are coming from Gartner, and they didn't provide in-depth examples of individual tools, but quite a bit of at least improvements regarding the coding. A lot of that comes from things like GitHub Copilot. And well, anyone who's worked with that will kind of understand why it's that. It allows you to very quickly write, especially if the code is repetitive. And to kind of, on a closing part, some of the capabilities and limitations. So obviously, this can improve the coverage because you can create more tests faster. It reduces time, and it can, and because it can also, we can provide it with a specific guidelines. It can improve the definition of new features. And we cannot ignore the limitations, which would be that it lacks the contextual understanding. So, as I mentioned when I talked about the feature definition, that sometimes they can be ambiguous. Well, they can also be ambiguous to an AI. And if we are trying to generate tests based on ambiguous feature definitions, the results may not be what we want. So we need to have a person in place to check that. Obviously, AI tools will have domain knowledge. So if you're working in a domain that is very specific or is not very and there hasn't been any training data for that AI model with similar data, it won't be as valuable for you than it might have been for some other projects. Well, there is always the ethical and bias considerations. So the models represent the testing data, the training data. So obviously, if the data has some biases in them, they will be visible in the output. As with any solution, there is a set of maintenance costs, and there's always a risk that over-reliant AI systems can have unexpected results. You might lose certain skill sets if you rely too much on them, or you might result in problems where AI is learning on its own. AI output is its input, and this kind of process can result in all kinds of malformed responses, basically. And on that note, that's it from my side. If you have questions, I will do my best to answer.
Thank you so much, Yanis. Maybe we have some questions from the audience. Yeah, we have one hand.
Hello. So this is a practical question. AI has generate strategies. So related in JSON, wants to valid. How do you do it with CSVs and analysis? I know if they are big enough to generate, they make certain mistakes, and I have taught myself a few times. Maybe you have some keys for force fit, for example, generating valid CSVs and XMLs.
Did you hear the question? Yes.
I heard some words, but not clear enough to understand.
Okay. So they should generate big data with JSONs, CSVs, and XML files. So I know how to do this JSON. I know that GenAI has API for that. Make valid JSON files. How do you do it with CSVs and XMLs? How to force to make it valid so it doesn't like create fake like wrong tags or make it misses the commas. Typical mistakes with CSV and XML.
So I think I catch that your question was related to data generation, but I didn't hear the kind of the key part. You mentioned that you're having something related to CSVs.
Yeah, so OpenAI right now we know how to generate JSON. How you generate CSVs and XML files?
It's actually well, the JSON functionality for OpenAI, they allow lots of kind of flexibility, but for the other ones, you can easily generate them by directly asking for that, to request the output to specifically be in a certain format. And it's not just CSV or XML, you could also request other formats. Yeah, you won't be able to include like a strict data validation, what you can do with JSONs. But you can still, if you provide clear enough guidelines of how the data should look like, you can generally get it. With XML, it's better. With CSV, at least in my experience, it's a bit trickier because, if you want to provide an example of it, it's going to be just text with commas, so it's a bit kind of vague. But you can still actually get, for the most part, decent results. At least GPT 3.5 is what I tested it. But yeah, you're basically what you're doing. You're explicitly stating that you want a response to be in a certain format, and it will usually do exactly that. Some cases it might do something else. Usually it will follow the guidelines.
Okay, yeah, thank you so much. Thank you so much for Yanis, giving him applause. And yeah. And right now we have like the second speaker. It's Povilas from Neurotechnology, and Povilas will talk about Open Llama 2 model for Lithuanian language. Yes. Background. Just one moment.
Can I try to switch the slides? This is nice. Doesn't work.
Not working? Yeah, it's working.
Works.
You can also see here because then we can see.
Can I begin?
Yeah.
So hello everybody. It's a pleasure to be here again as a presenter after I think 2 years. So the second presentation is Open Llama 2 model for the Lithuanian language. The research was conducted by Artūras Nakvosnas, me, and Vytas Mulevičius, and it was fully funded by Neurotechnology. So let me first shortly provide contents of this presentation.
maybe not filming. So stage.
Should I repeat?
Yeah, one moment.
Okay.
So we cannot film. Okay, that's right now.
So second presentation, Open Llama 2 model for the Lithuanian language. The research was conducted by Artūras Nakvosas, me, and 𝐍𝐸 Smulevičius. All of us are here today, so you can ask questions after the presentation if you would like. So this research was fully funded by Neurotechnology. And let me proceed to the first, describe the contents of this presentation. So at the first, we will shortly make a glance into what large language models, or LLMs, are. Then we talk about regional LLMs, which is a main topic of our research, discuss our contributions, and afterwards we provide some data and information about data which was used for training of the models, and discuss training details, also the conducted benchmarks of our model, and finally provide the conclusions or short take-home messages, what was said today. So modern LLMs are usually based on the transformer architecture, which was proposed by 𝐍𝐸𝐭𝐞𝐦 and co-authors in 2017. And currently it is very influential and like very much cited paper with more than 100,000 citations. Of course, there are other approaches which are being investigated, like recurrent neural networks and state space models like Mamba, but transformers is like main tool for LLMs. Also, with the release of ChatGPT in 2022, LLMs became a very influential field of AI and machine learning. They are used for various tasks. So at the moment, arguably, of course, LLMs are the most advanced form of human knowledge representation. So figuratively speaking, they are like a library you can talk with using natural language. So besides commercial models, open models also are constantly being released, and performance gap between commercial models and open models also constantly is being reduced. And of course, on the other side, training of language models is far from trivial task. Usually a large amount of the data is needed and considerable computational resources as well. So the problem we encounter is that most of the data which is available and which is used to train open models is English. So what about regional languages? So this question poses a problem we try to solve in this research. So first, at the end probably of the spring or the beginning of summer, we conducted a review of what models were available for what European languages. So the beginning of the table is in the slide. We see that most models follow Llama 2 or Mistral architecture. The size of the models are somewhere between 7 and 30 billion parameters. Also, we see that mostly full set of parameters was trained with small number of exceptions, which are showed as P letter, which means performance efficient fine-tuning methods like LoRa. So also we conducted investigation whether the associated scientific publication was attached to the corresponding model. So not all the models are like fully scientific projects, only about a half of them. So this is a continuation of this table, which shows similar tendencies. And At that moment, state-of-the-art open language models like Llama 2 and Llama 3 had virtually no support of Lithuanian language, and our motivation was to achieve Lithuanian-speaking LLMs from the checkpoints which virtually had no Lithuanian component. So our main contributions are the following. First, the two open 7 and 13 billion parameter LLMs for the Lithuanian language and their empirical evaluation, new data set consisting of more than 30,000 question-answer pairs about Lithuania and Lithuanian history, also translations of popular LLM benchmarks in the Lithuanian language, and a scientific article which described the aforementioned components. So let me now discuss details which were important for training of our model. So the first component is the training data. So language models usually are trained in two steps. First step is pre-training. So this pre-training is probably the largest step. In this step, the model learns the structure of the language. So we used the Lithuanian component of 𝐒𝐞𝐻𝐭𝐞 data set and next token prediction task with cross entropy loss, like it is common in the transformer-based models. So we conducted this step for both 7 and 13 billion parameter models, and afterwards we fine-tuned the pre-trained models using concatenated alpaca dataset, which was concatenated with the mentioned question-answer dataset. So this fine-tuning steps is this gives speaking style to the model. So if we would look to the other important training details, we see that we used one epoch for both cases. For model training, we used our in-house 𝐒𝐞𝐭𝐞 GPU clusters. Here we can see the learning rates, warm-up ratio, and other parameters which can be used to replicate our results if you would on your hardware. So the duration of hours needed to train also are provided, like 7 billion parameter models is almost twice fast to train, and 13 billion parameter model, it took almost 3,000 hours to train. So here we see the evolution of loss during pre-training for both checkpoints. The blue one is 7 billion parameter and red one is 13 billion parameter. So we see that 13 billion parameter model allows to achieve better losses during pre-training process. So now about benchmarks. We conducted two kinds of benchmarks. One is general perplexity evaluation, and another is language understanding benchmark. So perplexity is basically model's ability to predict next token given the previous tokens. So mathematically speaking, we have this expression. We have a sequence of tokens. The number of tokens is n, and we evaluate conditional probabilities of next token given previous information. So this measure is, of course, greater or equal to 1. In ideal cases, it is 1. And the lower perplexity indicates a better performance. So in some sense, it indicates how the model grasps the structure of the language. So we conducted the following experiment. During the pre-training epoch, we measured perplexity of mentioned question-answer data set, which was not seen during the training by the model because it was collected by ourselves. And we measured perplexity of concatenations, questions and answers input, each 10% of the training epoch. So we got the following graphs. The smaller model gave the larger perplexities as expected, and more complex 13 billion parameter model resulted in better perplexities. And eventually, during the training process, the perplexities decreased on the unseen data. So model trained. Now, another benchmark we conducted, it is implemented in a tool called language model evaluation harness, and this tool has like multi-benchmarks which are used in standard evaluation. So these language understanding benchmarks allows to assess LLMs across this wide array of tasks, primarily covering academic disciplines. And if imagine how it is being done, so LLM receives a textual input of the task, and basically it selects. It should select from the set of answers the correct one, and we measure the accuracies. So we made this experiment following the same scheme. Each 10% of epoch, we evaluate the model and measure the performances. So what we observed, this is, by the way, the data for 7 billion parameter model. What we observed is that in some cases, model really trained. So we see that in those 3 cases, the accuracy is increased. But interestingly, in some cases, model even was not able to achieve the initial performance. So we have a hypothesis why it can be. Probably it is associated with the quality of 𝐒𝐞𝐻 pre-training data. Like if you have 2 children, one children learns from web crawls, another learns from high-quality textbooks. Likely another child will be able to perform better. So the problem likely is in 𝐒𝐞𝐻 data set, which consists of web crawls of common websites. So similar dynamics was observed also in a model with 13 billion parameters. And now probably I can summarize this presentation to some take-home messages. So the first Open Llama 2 based LLMs for Lithuanian language were proposed with 7 and 13 billion parameter models. And during this research, the models like Llama 3.1 and Gemma 2 were released by technological giants Meta and Google. And those models already have good and strong Lithuanian components. So probably in the future, we will compare our model with those. But in this publication, we have not done this. So also we contributed with a new data set, which can be used for Lithuanian model training and evaluation, and which consists of 13,000 question-answer pairs about Lithuania. And we also translated standard benchmarks for language model evaluation into Lithuanian language and published them in an open repository. So in this way, we contributed to the standardization of Lithuanian language model evaluation. So here is our repository where all aforementioned components can be downloaded. And here you can access to archive publication which is about this research. So now probably my talk is finished. I am ready to answer your questions.
Yeah. Thank you, Paula. Yeah, amazing work. First model, open source Lithuanian language. So we're really happy. Maybe someone has questions about training, prompting. Okay.
So yeah, very interesting talk. I wonder, so is it easy to compare the performance of these models in the Lithuanian language with state-of-the-art in other languages? Like, how large is the gap in terms of perplexity, if that makes sense.
Actually, we compared the perplexities with Llama 3, which was state of the art at the moment. So actually, our perplexities of our models were better. But actually, if one would like to compare it with Llama 3.1, it is very easy. Just one function and like computation on one 100th GPU takes something like probably half an hour or something like that.
So do you have a feeling like is it an order of magnitude off, or is it like 2 orders of magnitude off from the state of the art model in the English language?
Hard to say actually. Need to check.
Also, just curious, does the tokenizer is sufficient, like a default Llama model, is it sufficient for the Lithuanian language, or is it really worth to fine-tune and retrain tokenization for the LLM in the thing?
Yeah, tokenizer also we trained our tokenizer.
In this case, is it arise any problems like some emojis and some symbols which are not currently in the corpus? So for those cases, it probably would not.
Yeah, probably. Thanks.
More questions?
Yeah.
Hello. First of all, big thank you here this job. I'm really big fan of this paper. I have read everything, and one question: in the paper, there is a duration in seconds and usually in hours.
Yeah, actually, it is typo in the paper. It is corrected in this presentation.
Because I try to imagine.
Yeah, it is in house.
Regarding the perplexity, if I understand correctly, so you use the same data set from 𝐒𝐞𝐩𝐭𝐞 with which was retrained, and then you used to calculate it again.
No, actually, during pre-training, we used 𝐒𝐞𝐻 data, and which step of 10%, like every 10% of 𝐒𝐞𝐻 data, we save the checkpoint and calculated perplexities of our proposed data set, which was not seen during the training. This question-answer data set.
Yeah, and I think you did an amazing job with translating all the benchmarks and with the QA test. I also tried this model myself. Unfortunately, I don't have a GPU, so I quantized your model using Llama framework. And have you thought about this quantization method, how it affects? What's your opinion?
Yeah, it allows to compress the model, probably, but in order to just run this model, you can do this by using CPU. So.
Yeah, I have a question about the benchmarks. Have you tried some benchmarks, and have you tried comparing just the existing available state-of-the-art like GPT-4 that is usually bad in grammar when you write in Lithuanian with the current models? So.
Yeah, speaking about language understanding benchmarks, probably it is possible easy to do that. But for perplexity benchmarks, I try to take logits from GPT output, and at least in Summer API doesn't allow to do that. So not all the benchmarks can be replicated. So if you have like more technical questions, this model was trained by Artūras, the first author of this article. And like I also made some benchmarking that mostly wrote this paper. So after the presentation, if you have technical questions, you can discuss with us. Maybe we can like get mutually interesting information from each other.
Thank you so much once again for your important work on the Lithuanian language. So my question also is about comparison in some way. Some of my colleagues work on African languages, and there's such a huge variety and complexity when it comes to starting with Arabic and other many languages. I was wondering if you also are you part of that kind of like community or movement, let's say from the conceptual movement, thinking about how different communities around the world are thinking about not like I wouldn't call it regional languages, but languages other than English, and whether you have been in any ways kind of sharing best practices or approaches, because it seems like in this specific case, you use what was in some ways available, let's put it that way. So what other communities are, what the approaches they are using to account for different complexities of the cultural sensitivity of the data set. So you can share some of that kind of thinking behind the scenes for this.
Yeah, if I understand correctly, the question was whether we like plan to do this research in other languages. Or so yes, there is such a plan for Baltic languages. So probably we will train smaller models and for like more wide array of languages, not just from Lithuania.
Do you have more questions? Yeah, just one more.
I don't know if follows this is the another model, Llama 3.2. So
Yeah.
have you any quick insights? Maybe tried it for a moment. Someone who has experience.
Yeah, I saw it yesterday. It was released, but I haven't opportunity yet to try it. But it's a small multimodal model, so probably it is like different kind of text.
Yeah. I think like the smaller 1D model should be like perform also quite good on different languages. More questions for us? If not, we also have like other paper out there, like Vilnius. So if you want, after like my couple of words, we go to like networking, and then you can ask him all the questions together for us. Yeah, so thanks so much. Amazing work. Yeah, so that's it for like today's meetup. Next meetup is in October. And right now we have a networking, pizzas probably should arrive very soon. And yeah, let's chat about LLMs and other applications. Thank you so much.